Okay. So, good morning, everybody. My name is Shunsuke Ide. I'm from the QST. Maybe I should start from explaining from which the institute I'm from and what the institute is doing in view of the international project. So, next. Okay, so QST is not doing only the fusion, but also doing other things, being also including the hospital. Do you have a pointer? Pointer, no. No? Okay. Okay. So, but these things are not the items talking today. So for the fusion, we have the two institutes here. One is Naka Institute, the other is Rokashu Institute. With the highlighted red in this Japanese map. And in view of the international collaboration, we have the two things, two big collaborations going on. One is the ITER. No? So as for ITER, as the Japanese domestic agency, we are procuring the ITER parts to make the ITER succeeded. The other thing is the broader approach, so-called broader approach. This has been done between Japan and EU, and we have the three projects under this broader approach that we are the implementing agency in the Japanese side. So for the broader approach, as I said, we have three things to do. One is the satellite tokamak project doing on the Naka side, which is my institution. On the other side, Rokashu institution, there are two activities related to the broader approach. One is related on demo design and R&D, and the other is for the something discussed yesterday, today, the related to the IFMIF, the prototype accelerator development. But let me focus only on the Naka side. But firstly, for the ITER, as I said, we are the Japanese domestic agency to providing the many parts to ITER, like 9 toroidal field coils. These are already delivered, and also the heating power source, which is called gyrotron. Also, this we have delivered to the ITER, and the other things. And we are developing these very specialized things, which is not something you can find in the shelf of the supermarket or Amazon. So this is called for components, and we are developing these components together with suppliers. And the other thing is the satellite tokamak project under the broader approach. We are doing this in collaboration with the Fusion for Energy. And this is to contribute to the early realization of the fusions. And we have the three objectives to support ITER and also supplement ITER towards the demo. And also we would foster the younger generation. And the DT6SA is the next largest machine to the ITER. So for the time being, before ITER appears, we have the largest tokamak in the world. So we have actually start operating these machines, and we succeeded to have the first plasma in the 2023 like this. And as I said, this is the largest plasma in the world, and we have a Guinness World Record received last year. And the machine is under enhancement in preparation of the heating experiment in 2026, next year. So this is the sketches how we are contributing in these two projects. For the ITER, we are one of the domestic agencies in the 7 parties and under the ITER organization. So Alberto is our big boss, so we have to serve for him. And we are collaborating with each suppliers, coil suppliers, gyrotron suppliers, and deliver this part to Alberto. And for the GT6SA, we doing something similar to the ITER organization, in this case together with the Fusion for Energy. And also we are procuring the our responsible parts like vacuum vessel, the equilibrium field coil, with collaborating with the suppliers. I'm here not to advertise my institute, but to tell you what we have learned from these collaborations. I think now you understand what I'm saying is a bit more realistic. So, but what I'm going to talk is not that complex. It's very simple. Rather, too simple, you already have taken it for granted. You have many countries in the EU side. But again, I would like to say, talk about what I have learned, at least within these things. So, the questionnaire we got for this talk is that what is the good mechanism to run this countries project? So, there will be the simple keywords. The one keyword is the simple mutual understanding. This is too simple to say and also to hear, but it is very difficult to establish. So at the beginning of this project, the conversation is something like the fight. Each side, Japanese side, EU side, just say what each side wants. In these 6 months or something like that, there appeared one word which I started hating very much. That is deal. So I think you have heard this terminology in newspapers and something like that. But this kind of project cannot be established in the context of the deal. But we need some mutual understanding. This is the important things. So necessary to understand, especially differences in the purpose of each side has their own purpose for joining the project, and also the background culture, and the commercial practices, legal philosophies. There are so many differences at each side. So at the very beginning, this was the big barrier to cooperate with. And to overcome, what is important is the common language or terminologies. In order to develop this, the discussion, was the key issues. And this is more like a philosophic side or, the higher management side. But this is also true for the engineering side. So sharing the engineering basis, the clear identification of the interfaces, something like this is the indispensable as well. This is kind of the common language or terminologies. So especially for the integration of a complex system like fusion power plant, this is very important. And the other questionnaire we got for this session is what mistake we should avoid to go forward. So I would not say each mistakes, but most of the mistake came from these things, misunderstandings or lack of the common language. So common language is more important, especially with suppliers, because they do not know much about the fusion. No? So the common language in this case can be the CAD data or the details of the tolerance, gaps, forces, heat, irradiation, these things. But we need to establish the common language to talk about. And as fusion is growing up, internationalization would be the more important. For in this sense, establishment of fusion codes and standard is required to go forward. So for the time being, we can use standard for the GIS or standard for the American standard, but it is a bit complicated. So this is something we need to go forward. So in order to overcome these things to establish mutual understanding, is the best way to have meetings and discussions. For that, we have many meetings here to discuss the prospects of the project and also the detail of the engineering things. This is the same for the ITER, I think. Now ITER has many meetings to share and confirm the purpose and the details and the interfaces. For ITER, maybe a bit too many meetings, but meetings is important. And the other keyword is, as you have heard a couple of times during these 2 days, is the integrations. Yes. So since the system is very complicated, I'm finishing in 2 lines. There should be some command center to integrate every these sub systems, since the fusion plant is very complex. For the time being, ITER project and also the broader approach project, EIO or we, QST FOE, are doing this command centers because we are familiar with the tokamaks and the fusions. But towards industrializations, this knowledge, how to build, how to identify the purpose, these things, and experience on integrating a whole fusion planet should be established also in the industrial side. Up to demo or something like that, maybe the public side would take lead to the building that's the system and leading the project. But at certain time in the commercializations, private companies would do for that. So we need to transfer this experience and information to the industrial side along with the project is ongoing. So for this, more involvement of industries in ongoing projects would be recommended, since we would not have so many chances to get them involved, not so much the machines to be built up to the commercializations. This is my view, especially one from the public side, because as a public side, our ultimate goal is to provide power on the grid for the public. And give me a bit, 1 minute. So. For this, as I said, the common language is very important. Common language, in other sense, is the more definition of each terms. In these 2 days, we're discussing about, still we are a bit unclear what is our goal, what is the commercialization target, or that kind of things. In this sense, our goal is for the public, as I said, but this is not only the place we should go. There would be some area fusion can be commercialized. Having seen many IT companies investing to the private sectors, and also the recent big thirsty for the electricity of the data centers. Our goal is establishing a power plant, a kind of gigawatts class. But even for the smaller size, half gigawatt class or something like that, could be accepted for each, the data centers or something like that. I think this is something some of the private sectors are aiming for. So on this sense, we share the same similar opinion what Richard said this morning. Yeah. Okay.
Sure.
That's all.
Thank you so much. Thank you.